Okay, we're looking at Algebra 1.5, monitoring progress, numbers 9 through 11. We've basically got three word problems here. The first one asks, it says that if you have a fever of over 100 degrees, or temperature over 100 degrees, it's considered a fever. So if someone has a temperature of 37 degrees, well, it's 100 degrees Fahrenheit. If your temperature is 37 degrees Celsius, do you have a fever? So is 37 degrees Celsius greater than 100 degrees Fahrenheit? Or I suppose technically we should be asking greater than or equal to. Well, they give you a formula for this. Let's take a look at what the formula is. They say that Fahrenheit, degrees Fahrenheit, is equal to 9/5 degrees Celsius plus 32. By the way, if you're curious, so we just have two different temperature scales. The Fahrenheit one is the one we use around here, where a hot day is like 90 degrees. In like England and a lot of Europe, places like that, they use Celsius, where a hot day might be like 32 degrees. So in the Celsius scale, water boils at 100 degrees. In the Fahrenheit scale, water boils at 212 degrees. In the Celsius scale, water freezes at 32 degrees. And on the on the Fahrenheit scale, water freezes at 32 degrees, and on the Celsius scale, it freezes at 0. So the Celsius scale kind of goes from 0 to 100, whereas the Fahrenheit scale goes from 32 to 212, from freezing to boiling water. Kind of a long, complicated history why that turned out the way it is. Basically, Fahrenheit was a glass blower who made thermometers. Anyways, so we're just going to plug in our 32 degrees for C in Celsius and see what we get. So let's see. We're going to go Celsius is 37, and that's 9/5 37 plus 32 equals F. Now, a little trick here when you're multiplying by fractions. Notice 37 times 9/5, that could be kind of complicated, but really 37 times 9/5 is just 37 times 9 divided by 5. Okay, so we're going to get out our calculator. So 37 times 9 on our calculator is going to turn out to be 333 over 5 plus 32. And then we're just going to have to go ahead and divide that by 333 divided by 5 plus 32. Again, we'll just get our calculator and do it all at once. And we get 98.6 degrees Fahrenheit, which is normal body temperature. Your friend does not have a fever. All right, for problem number 10, it asks you, how much would you have to invest? How much money would you deposit in a simple interest account to earn $500 in interest in 5 years at a 4% annual interest rate? So we're going to use our simple interest formula. The I in this formula is for interest earned. The P is for the principal invested. The R is for the interest rate as a decimal. And the T is for time, which is usually in years, because the interest rate in these problems is usually an annual rate. So basically what it means is that if you invest some principal, then you will get paid a certain amount of money per $100 you invest, say. That's your interest rate. And you'll get paid so often. So it's going to be like so much money per day, per month, per year, or whatever. And then the amount of time is how many of those units of time. So if it's, say, 5% per year, that's $5 for every 100 every year. And then you'd have to know how many years that you're getting your money's invested for. So in this case, we know that the interest rate is going to be, let's see, the interest earned is going to be $500. So we want this to be $500. The principal invested, we don't know that. The interest rate as a decimal is going to be 4% or 0.04, and the time in years is going to be 5 years. So let's set this up. So it's interest, that's the $500, equals principal. We don't know that, so we're just going to leave it as P. The R is 0.04, and the T is 5. So the first thing I would do is I would just multiply the 0.04 and the 5 together. And that's going to give us 500 equals P times 0.2. And now to solve for P, we're going to have to take both sides and divide them by 0.2 by 0.2, or 2/10. I'm going to kind of move this up just a little bit here so that we can alright. So let's see, on this side that's just going to leave us with P by itself, and on this side 500 divided by 0.2 is going to be, use your calculator here folks, $2,500. Oh boy, last one, some guy with a truck. He's delivering things, and oh my goodness, I think his name is Jerry. He looks like this. For some reason he's driving 60 miles an hour when he's delivering, but only 45 when he's on his way back. And I looked at the solution that they gave. That's just too complicated for us. It's not how I would have solved the problem anyway, so we're going to skip this one.